In this video, we have a spring that is hung horizontally with a spring constant of 70,000 newtons per meter, and a 3 kilogram mass is attached. And you're going to pull the spring back 5 centimeters from equilibrium and then let it go. And we want to know what the total energy of the system is, what the maximum velocity the mass experiences, and what the velocity is at half the amplitude. So the first thing we're going to do is take advantage of the fact that when you're pulling the spring back and releasing it, the fact that you're pulling it back a certain amount sets the amount of energies in the system. So we know the potential energy of the spring is 1/2 k. Normally we would use x squared, but we want the maximum. And the amplitude A is the maximum distance that the mass or the spring stretches out from equilibrium. So we're going to take 1/2 times the spring constant times that maximum distance from the equilibrium, so the 0.05 meters or 5 centimeters. And that gives us 87.5 joules. For part B, we want to know what the maximum velocity is. Well, we also know at the maximum velocity, all the potential energy has been turned into kinetic energy. So the maximum velocity is going to occur when all of the energy is kinetic energy. So I plugged in the energy I found in part A, and I've now solved for velocity, which is 7.64 meters per second. Now there is a different way you could do this, using the velocity equation that was derived. Maximum velocity occurs when the spring is at equilibrium. The amplitude doesn't change, it's a constant for that particular problem. So pulling the spring back and releasing it sets in what the amplitude is. So this would still be the 0.05 meters, but because this x value corresponds to the velocity you're finding, if you want the maximum velocity, which occurs at equilibrium, that's when x equals 0. So you would plug in 0 there, and that would also get you the same answer of the maximum velocity. Now, instead of wanting the maximum velocity when x equals 0, I want to know what the velocity is when you're halfway between the 5 centimeters and 0. So that means the amplitude stays the same, but x is now half of 5 centimeters, or 2.5 centimeters, which I've now converted into meters. And that changes the velocity. That velocity should be in between this value and 0. And you see that the answer is actually between 0 and 7.64.